Hey, it's James. Welcome to episode 7.2 of the Inversiverse. In this presentation, we're going to explore the fascinating subject of epigenetics, aspects of the brain and its function within the body, the concept of neuroplasticity, diets, and dietary effects on the body. We'll delve deeper and analyze various real-life examples and experiences throughout the presentation. So let's start now with epigenetics. What is epigenetics? Epigenetics is the study of heritable changes in gene expression that do not involve changes to the DNA sequence itself. Instead of altering the genetic code, known as the genotype, epigenetics affects how genes are turned on or off. This is known as the phenotype, through biochemical modifications. These modifications influence cell function, development, and even disease risk, and environmental factors, stress, toxins, and diet can affect them. The picture shown shows epigenetic mechanisms are affected by these factors and processes: development in utero and childhood, environmental chemicals, drugs, pharmaceuticals, aging, diet. Pictured chromosome, chromatin, methyl group, DNA strands. DNA methylation, methyl group, an epigenetic factor found in some dietary sources, can tag DNA and activate or repress genes. Histones are proteins around which DNA can wind for compaction and gene regulation. Health endpoints: cancer, autoimmune diseases, mental disorders, diabetes. Histone modification. The binding of epigenetic factors to histone tails alters the extent to which DNA is wrapped around histones and the availability of genes in the DNA to be activated. Key mechanisms of epigenetic regulation. 1. DNA methylation. Methyl groups attach to DNA, silencing or activating genes. Increased methylation usually turns genes off. This is known as gene silencing. Decreased methylation can activate genes, sometimes leading to diseases like cancer. Number 2. Histone modification. DNA is wrapped around histone proteins which can be modified by acetylation, methylation, or phosphorylation. Acetylation equals loosens DNA, allowing genes to be activated. Desilylation equals tightly packed DNA, silencing genes. Number 3. Non-coding RNA, ncRNA regulation. MicroRNAs can block gene expression by degrading messenger RNA, preventing protein production. So this poses the question, can epigenetics be altered by food? Yes, diet plays a crucial role in modifying epigenetic markers. Certain foods contain bioactive compounds that can turn genes on or off by influencing DNA methylation, histone modification, and microRNA activity. So it's not a conspiracy theory when people highlight the fact that they're altering the DNA. They don't have to actually alter the DNA, they can modify the genes, which has an effect on the DNA. Let's look at some foods that have a positive effect on our brains and bodies, influenced by epigenetics, how the brain functions and integrates within the body, before examining some negative foods and examples of aspartame, commonly found in Pepsi and Coca-Cola, and GMOs found in processed foods. Foods and their epigenetic effects. Green tea. Epigenetic mechanism inhibits DNA methylation. Effect may suppress cancer genes. Turmeric modifies histones and miRNA. Effect: anti-inflammatory and anti-cancer properties. Food: broccoli. Epigenetic mechanism increases histone acetylation. Effect: detoxifies carcinogens. Folate, leafy greens, legumes, promotes DNA methylation, essential for fetal development and brain health. Omega-3 fatty acids, fish and flax seeds, alters histone modification, and the effect reduces inflammation and supports brain function. Resveratrol, which is red wine, grapes. The epigenetic mechanism activates sirtuins, longevity genes. The effect is anti-aging and metabolic health. This is why I say it's good to drink red wine. Choline, eggs, liver, nuts. Epigenetic mechanism supports DNA methylation. The effect affects brain development and memory. Caloric restriction modifies gene expression, which is linked to the effect of longevity. So let's now look at the structure of the brain. The brain is a complex organ that serves as the body's command center. It is made up of billions of neurons and glial cells, which help process and transmit information. It can be divided into several key regions. A. Major parts of the brain. Cerebrum, which is the largest part. This is responsible for higher thinking, sensory perception, voluntary movement, problem solving, and emotions. The cerebellum controls balance, coordination, and fine motor skills. The brainstem connects to the brain to the spinal cord and regulates basic survival functions such as heart rate, breathing, and digestion. B. Key lobes of the cerebrum. The frontal lobe. Decision-making, planning, problem-solving, voluntary movement, personality, and social behavior. Parietal lobe processes sensory input such as touch, temperature, pain, and spatial awareness. The temporal lobe is responsible for hearing, memory, and language processing. The occipital lobe primarily processes visual information. C. The limbic system, emotional and survival center, part of the brain. Amygdala involved in emotions, fear, and memory formation. The hippocampus is essential for learning and memory. The hypothalamus regulates body temperature, hunger, thirst, sleep, and hormonal balance. So how does the brain integrate with the body? The brain communicates with the rest of the body through the nervous system and the hormonal system. A. Nervous system communication. The central nervous system, CNS, brain and spinal cord, processes information. The peripheral nervous system, PNS, carries messages to and from the central nervous system via nerves. The autonomic nervous system, ANS, regulates involuntary functions like heartbeat and digestion. These are carried out subconsciously in the background as we carry out our everyday jobs. The somatic nervous system controls voluntary movements. These are the movements that we consciously are aware of and decide to make. Hormonal communication. This is carried out through the endocrine system. The brain, the hypothalamus and the pituitary gland release hormones that control glands like the thyroid, adrenal glands, and reproductive organs. Hormones regulate mood, metabolism, growth, and stress response. The function of the brain, what it does, and how. The brain is responsible for A. Processing information. The brain receives sensory input from the eyes, ears, skin, and other organs. It processes this information and sends commands to muscles and organs. B. Motor control and movement. The motor cortex in the frontal lobe sends signals to muscles for movement. The cerebellum fine-tunes coordination and balance. C. Thinking, emotion, and memory. Thoughts, logic, and problem-solving occur in the frontal lobe. Emotions are processed by the limbic system. Memories are stored and retrieved using the hippocampus. D. Body regulation and survival functions. The brainstem controls automatic functions like breathing and heartbeat. The hypothalamus maintains homeostasis, which is known as body balance. Processing information, how it works. The brain receives sensory input from 5 senses we know as sight, sound, touch, taste, and smell, through specialized receptors in the eyes, ears, skin, tongue, and nose. The input is transmitted to the thalamus, which acts as a relay center and directs the information to the appropriate brain region for processing. The brain then interprets the data and responds by generating thoughts, emotions, or physical actions. For example, if you touch something hot, sensory neurons in your skin send signals to your spinal cord and brain. The brain processes the heat information, recognizes danger, and quickly sends motor signals to your hand to pull it away. The role of brain waves in information processing. The brain operates using electrical signals that create brain waves. Delta waves are the slowest. These usually occur during deep sleep and restoration. Theta waves are creativity, daydreaming, and meditation. Alpha waves occur through relaxed states, but alert states also. Beta waves is active thinking, problem solving. Gamma waves are known as the fastest, and these are high-level cognitive processing and memory recall. Motor control and movement. How it works. The primary motor cortex in the frontal lobe sends signals through the spinal cord and nerves to control voluntary muscle movements. The cerebellum refines movement, ensuring smooth coordination and balance. The basal ganglia helps regulate movement intensity and prevent unwanted movements. For example, when you decide to walk, the frontal lobe initiates the movement, the spinal cord sends signals to your leg muscles, and the cerebellum ensures balance. Motor, learning, and adaptation. Repeated practice of movement, like learning to play an instrument, strengthens connections between neurons, therefore improving skill and muscle memory. Thinking, emotions, and memory. A. Thinking and problem solving. The frontal lobe, the center of reasoning, decision-making, problem solving, and planning. The prefrontal cortex involved in self-control, focus, and long-term planning. Example, when solving a math problem, your prefrontal cortex analyzes numbers, recalls formulas, and strategizes the solution. Problem plus thinking equals the solution. Emotions. The limbic system is the emotional hub. Amygdala processes fear, aggression, and pleasure. Hippocampus links emotions with memories. The hypothalamus controls emotional responses via hormones. For example, seeing a loved one triggers the amygdala to produce a feeling of joy and connection. Memory and learning. The hippocampus converts short-term memory into long-term memory. The prefrontal cortex stores working memory, known as temporary information. The basal ganglia stores procedural memories, such as riding a bike, riding a horse, or playing an instrument. Another example, when learning a new language, the hippocampus helps store vocabulary, while the basal ganglia store muscle memory for pronunciation. Body regulation and survival functions. A. The autonomic nervous system, responsible for sympathetic system, activates fight or flight responses. These are known as stress response. The parasympathetic system activates rest and digest mode, known as relaxation. The homeostasis, body balance. The hypothalamus regulates temperature, such as sweating when hot, shivering when cold. Hunger and thirst, triggered when the body needs nutrients. Sleep-wake cycles, which are regulated by melatonin. For example, if blood sugar drops, the hypothalamus signals hunger, prompting you to eat. So why does the brain work this way? A. Evolution and survival. The brain evolved to prioritize survival by quickly processing threats, controlling emotions, and adapting to the environment. For B. Energy efficiency. Despite making up only 2% of body weight, the brain consumes 20% of energy. It constantly optimizes function to conserve energy, focusing only on important tasks. Consciousness and self-awareness. C. The default mode network is active when we self-reflect. The prefrontal cortex helps develop a sense of identity and purpose. D. The role of the subconscious mind. Most brain processes occur below conscious awareness, influencing thoughts, habits, and behaviors. Example, breathing and digestion happen automatically, freeing mental energy for conscious thought. And this is something when people question other people's thoughts, feelings, and beliefs, you're met with a fight or flight response. These people are unable to process their subconscious feelings in a conscious manner. So if you say something that they disagree with, they will often fight back or cause a situation that involves emotions rather than be able to consciously, rationally, and process the information to have a rational conversation. The brain is an incredible organ. What we can achieve by fully embracing its capabilities and having a full understanding of it can lead us to limitless possibilities. It is known to be plastic in that it can self-heal, learn and adapt to new processes, reroute and form new neural pathways, known as synaptogenesis, and strengthen or weaken existing connections, which is known as synaptic pruning, and much more. Even when inhibited, for example, if an individual loses their sight, the brain can adjust to improve an individual's hearing and enhance their experiences. This paradox and phenomenon is possible through the brain's programming to function within the body to efficiently keep itself safe. This phenomenon is known and as termed by neuroscientists and neuropsychologists as neuroplasticity, and it can be used to help the brain and body heal from physical, mental, and psychological trauma. Unfortunately, the same brain functions can be used by those with nefarious desires, which leads to an individual having their senses and perceptions, identity, self-awareness, and their mental models and constructs of reality corrupted, and or perceptions of reality skewed over time. Over the coming slides, I'll highlight and elaborate with various examples of how this is achieved, building on previous episodes of the Inversiverse, so if you've not checked them out, please start with episode 1. Why is neuroplasticity possible, you might ask? 1. Because the brain is adaptive. Neurons, known as nerve cells, communicate through synapses, and these connections are malleable. 2. Experience shapes wiring. What you repeatedly think, feel, and do strengthens specific circuits within the brain. 3. Neurons that fire together wire together. This is known as the Hebbian principle, Donald Hebb, 1949, and he describes how repeated activity between neurons increases their efficiency. How neuroplasticity helps us heal. 1. Recovery from trauma or injury. After a brain injury or stroke, uninjured areas of the brain can take over functions that were damaged. Example, constraint-induced movement therapy, CIMT, helps stroke patients recover motor skills by forcing the use of the affected limb. 2. Healing from trauma, PTSD, and emotional pain. Trauma creates strong emotional associations in the amygdala and the hippocampus. Neuroplasticity allows us to reframe experiences, calm emotional triggers, and build new, empowering associations. Study Van der Kolk's Work in the Body Keeps the Score outlines how mindfulness, movement, and expressive therapies help rewire emotional response circuits. 3. Overcoming anxiety, depression, and addictions. Negative thought loops and behaviours reinforce specific pathways. We can create new thought patterns and reduce reactivity through cognitive behavioural therapy, CBT, mindfulness, journaling, and what's known as visualizations. Study Davidson and Lutz, 2008, found that mindfulness meditation changes the brain structure, increasing cortical thickness and altering default mode network activity. Reference David R.J. Lutz, 2008, The Buddha's Brain, Neuroplasticity and Meditation, Nature Reviews, Neuroscience. So how can we rewire the brain, you might ask? 1. Awareness of habitual patterns. You can't change what you don't observe. Journaling helps us achieve this. We can use therapy or meditation, which can help reveal negative thought loops and triggers. 2. Repetition plus emotion. The brain rewires when something is repeated frequently with emotion. We can practice new thoughts, change our behaviours or emotional responses consistently. Example, gratitude journaling rewires attention towards positivity. We can use visualization. Mental rehearsal activates the same circuits as real-life actions. Athletes and stroke patients use this to build skill and confidence. Study Pascal Leon et al. Showed that imagining piano practice changed motor cortex activity almost as much as physical practice. Reference Pascal Leon et al. 1995, modulation of muscle responses evoked by transcranial magnetic stimulation during the acquisition of new fine motor skills, J. Neurophysiology. We can use mindfulness and meditation. These practices strengthen the prefrontal cortex, which is willpower and focus, and weaken the amygdala's fear response to those actions. 5. Consistent positive input. Rewiring requires time. You must replace old circuits, not just suppress them. Therefore, daily practices like affirmations, breath work, cold exposure, creative flow, or embodiment of all contribute to this process. The types of neuroplasticity that we are now aware of. Type, structural, description, physical changes in brain matter, e.g. increased grey matter in meditators. Functional, brain regions shifting tasks, e.g. after stroke. Synaptic, changes in strength of connections, which is learning and memory. And compensatory, brain areas adapting to injury or limitation. Now that we've explored the brain, its structure, integration within the body, the control and function of its various regions, and its remarkable capacity for neuroplasticity, we can begin to understand how these systems shape our perception of reality. We've seen how our sensory experiences form an interconnected feedback loop between the brain and body. When this connection is corrupted, whether through physical injury or deeply embedded false beliefs, it can result in pain, not just physical, but also emotional and psychological anguish. These layers of suffering often manifest simultaneously, creating a storm of feelings, thoughts, and sensations we must learn to process. Importantly, we discovered the brain's potential to help the body heal, both physically and mentally. When given the right conditions, this insight opens the door to a powerful question. If the brain can heal, can it also be deceived? And if so, how can that deception shape an entire person's perception of reality? Let's consider a scenario. At birth, we are often described as tabula rasa, blank slates, a concept rooted in philosophy of John Locke. As we grow, our beliefs, memories, and emotional patterns are formed largely through experience. The influence of caregivers, peers, and the broader social system we are immersed in, like the education system, as previously discussed in episodes of the Inversiverse. So what happens if that influence is negative or intentionally misleading? If a person is told a falsehood from the moment they are capable of understanding language, and that falsehood is reinforced by everyone around them, how would they ever come to realize it wasn't true? They might only experience a vague sense of emotional discomfort known as cognitive dissonance, as Leon Festinger described it, without being able to name its cause. This raises fundamental epistemology questions. How do we distinguish truth from illusion? How do we know whether something is real or fabricated? Here's a simple example. Imagine a child placed in a room at the age of 3, shown an hour of television per day. That child is never allowed to question, discuss, or explore what they've seen. If the television consistently presents the idea that the moon is made of cheese, through animations, scientific reports, and even news segments, the child will grow up believing this to be true. Why would they question it? Their reality, as shaped by their limited experience, affirms this illusion. Another metaphor, suppose I build a full-scale model of a car, shiny exterior, tinted windows, realistic tires, but leave the interior hollow, with no engine, no mechanics. From a distance, it looks like a real functioning car. You'd have no reason to doubt its authenticity. Only upon closer inspection might you realise it's a facade, an illusion, such as the car pictured below, which is made of cake. Manufactured realities and thought reform. These examples are simplistic compared to the complex systems of indoctrination operating at society levels. In Noam Chomsky's and Edward S. Herman's Manufacturing Consent, the authors argue that mass media serve not to inform the public but to shape opinion in the service of elite interests. Through selective framing, repetition, and omission, the media becomes not a tool for free speech but of subtle control, creating a version of reality that aligns with economic and political agendas. Similarly, Robert Lifton's theory of thought reform, commonly known as brainwashing, outlines the psychological mechanisms used to manipulate and control individuals, particularly in closed or coercive environments. Lifton identifies key features such as the milieu control, controlling the environment and communication, loading the language, using buzzwords or slogans to reinforce ideological purity. In the UK, the Labour government and all the previous governments, when something bad would occur, often afterwards they would use loaded language such as lessons have been learned, or we're all in this together, or words such as the cost of living crisis, and confession, encouraging self-criticism to reinforce group norms. These tactics are not limited to cults or totalitarian regimes. They can, and often do, appear in more subtle forms within the mainstream culture. In both cases, the goal is the same, and that is to control perception and to control behaviour. An example where someone is closed off and has their reality shaped is The Truman Show, a film, a mirror to our condition, a modern cultural allegory that reflects these themes in the film The Truman Show. In it, Truman Burbank lives his life within a constructed reality, a massive television set, unaware that every aspect of his world is artificial. Everyone he interacts with is an actor, his environment is curated. The truth is hidden not by force, but by a conspiracy of silence and consensus. This mirrors our own reality more than we like to admit. How much of what we take for granted, our news, our education, our cultural values, is truly ours, and how much has been constructed for us, is a question. Truman's awakening begins not with a dramatic revelation, but with a series of small inconsistencies, things that don't quite feel right, just like many people today who begin to question their environment, their media, or their beliefs. His journey towards truth begins with doubt and discomfort, which we know as cognitive dissonance. It's becoming aware of our emotions that help lead us to the journey of truth. Let's now look at cults, groupthink, and collective illusion. Cults provide a concrete, real-world example of how group consensus can override individual reality. In cult environments, leaders often use isolation. One such example of isolation is when they lock the country down in the UK and around the world to flatten the curve with COVID. Repetition. The fearful news being projected on everybody day after day with the numbers of COVID deaths rising and rising, when in actual reality we found out many of the COVID diagnoses weren't actually COVID because of the 93% false positives. They use fear to enforce belief systems that outsiders think unbelievable, which we then, at the time, question the narrative. But for those inside, the illusion is total. Groupthink, a concept studied extensively in psychology that shows how the desire for harmony and conformity can suppress critical thinking and dissent with any group. For example, when we were asked to wear masks, people got angry if you didn't wear a mask, yet there was plenty of evidence with science peer-reviewed papers that show masks do not do anything. The holes within the masks are far greater in scale than the size of the bacteria. Therefore, bacteria just pass through the masks. It's not just cults, but corporations, governments, or even friend circles force for harmony and conformity to think the same, known as the hive mind. This isn't just about isolated incidents, it's a reflection of a deeper truth. When our sources of information, our sense of identity, and our social validation are all tied to a single constructed narrative, it becomes extremely difficult to step outside of it. Oh, you're a conspiracy theorist. You're crazy because you think differently to me, as often projected by individuals who aren't aware of their own realities. Those who do are often branded as dangerous or mentally unstable, which I've just highlighted, not because they are wrong, but because they threaten the cohesion of the group. So let's conclude, seeing through the illusion. Our brains are capable of extraordinary healing and growth, but also vulnerable to manipulation. When we understand how our perceptions can be shaped by the media, education, culture, and collective norms, we begin to reclaim our autonomy. The question then becomes, when the illusion cracks, will we look away, or will we step through into the unknown and help others to do the same? This is my effort to help people see through the illusion that has been cast over our society and the world on a whole. Let's now look at how poor diet and examples of aspartame and GMOs can play a significant role in stopping us from seeing through the illusion and the weaponization of foods that can distort our perceptions and negatively affect our bodies, leading to many illnesses including cancer, before concluding what has been presented through this episode of the Inversiverse. Let's look at aspartame. Aspartame is an artificial sweetener made of 3 primary components: aspartic acid, an excitatory neurotransmitter, phenylalanine, an amino acid that affects neurotransmitter balance, methanol, a toxic alcohol that metabolizes into formaldehyde, and a toxicology report from the UK government highlights that formaldehyde is a carcinogen. So when people question, does aspartame cause cancer and why are cancer cases rising, it's because it contains a carcinogen. There's no denial of that. It's listed, it's highlighted in this very breakdown of what aspartame is. So let's take a detailed look into the aspartame breakdown in the body. Aspartame is hydrolyzed in the small intestine into 3 components: aspartic acid, excitatory neurotransmitter. In the brain, aspartic acid functions as an excitatory neurotransmitter, stimulating neurons. Excessive levels can lead to excitosity, where neurons become overstimulated and damaged. Phenylalanine, amino acid dopamine nephrephrine precursor, converted into triosine, precursor to dopamine, nephrephrine, and epinephrine. Excessive phenylalanine can disrupt neurotransmitter balance, which directly affects moods, cognition, and behaviour. In individuals with phenylketonuria, phenylalanine can accumulate to neurotoxic levels. Methanol, toxic byproduct CH3OH, metabolizes in the liver, which produces formaldehyde and formic acid. Formaldehyde is a neurotoxic and can cause oxidative stress, leading to cellular damage. Chronic exposure is linked to neurodegenerative diseases such as Alzheimer's and dementia. Chemical breakdown of the brain, neurochemistry perspective. The brain is composed of lipids, proteins, neurotransmitters, and ions, playing critical roles in its function. Here's a table of neurotransmitters, the chemical messengers. Neurotransmitter glutamate. Its function is a primary excitatory neurotransmitter. GABA is an inhibitory neurotransmitter. Dopamine is mood, pleasure, and motivation. Serotonin, mood regulation, sleep, appetite. Acetylcholine is memory, learning, muscle control. Nephrephrine is alertness, stress response. The effect of aspartame is it suppresses dopamine and serotonin. Therefore, it affects directly your mood, pleasure, motivation, mood regulation, sleep, and appetite. Lipid composition of the brain. The brain is 60% fat, with major lipids including phosphatidylcholine, involved in cell membranes, and acetylcholine synthesis. Sphingomyelin, critical for myelin sheath insulation. Docosahexaonic acid supports cognitive function and neural membrane fluidity. Brain metabolism and chemical processes. The brain primarily relies on glucose for energy via glycolysis, breakdown of glucose into pyruvate. Krebs cycle produces ATP and neurotransmitter precursors. Pentose phosphate pathway generates NMDHPH for neurotransmitter synthesis. Psychological and neurological effects of aspartame. Aspartame consumption can influence the chemical equilibrium in the brain. 1. Neurotransmitter disruption. Excess phenylalanine competes with other amino acids, leading to reduced serotonin and dopamine productions. This imbalance can cause mood swings, anxiety, and cognitive impairment. Excitotoxicity from aspartic acid. High levels of aspartic acid overstimulate glutamate receptors, NDMA receptors, leading to neuronal damage and cell death, which is linked directly to neurodegenerative diseases like Alzheimer's and Parkinson's. The brain literally begins to break down, loses the fats, and shrinks. Oxidative state, stress, and neuroinflammation. Methanol metabolizes into formaldehyde, which has previously been highlighted through toxicology reports to be a carcinogen, generating free radicals and increasing oxidative stress. Chronic exposure is linked to neuroinflammation and cognitive decline. Overall inflammation within the body, which harbours cancer cells. Let's now look at genetically modified organisms, GMOs, commonly found in many processed foods, especially in Chinese cuisine, that uses soy-based ingredients, corn derivatives, and vegetable oils. Let's break down the common GMO-derived ingredients, their chemical impact on the body, and their potential psychological and neurological effects. Common GMO ingredients in Chinese foods include soy products, glycine max, common forms, soy sauce, tofu, soybean oil, soy lecithin. Genetic modification, engineered for glyphosate resistance, herbicide-tolerant Roundup Ready soy. Chemical breakdown, soy protein can mimic estrogen affecting hormones. Isoflavones act as phytoestrogens, can disrupt endocrine balance. And soy lecithin, found in processed foods, affects brain lipid composition. Corn derivatives, ZMAs, common forms, cornstarch, high fructose corn syrup, corn oil. Genetic modifications, engineered for pest resistance, BT corn. Chemical breakdown, high fructose corn syrup disrupts insulin regulations linked to neuroinflammation. So this is why we have a huge number of people becoming diabetic, because all the processed foods disrupt the insulin creation. Corn oil high in omega-6 can promote brain inflammation. Monosodium glutamate, purpose, flavor enhancer, impact on brain chemistry, acts as an exotoxin, overstimulating neurons, triggers excess glutamate leading to excitotoxicity, which is linked to headaches, anxiety, and mood swings. Canola oil, derived from GMO rapeseed. Chemical effects, high in omega-6 fatty acids, promoting neuroinflammation. Oxidized fats produce aldehydes, potentially toxic to neurons. Artificial preservatives and flavor enhancers. Sodium benzoate converts to benzene, which is a neurotoxin. Benzenes and benzodiazepines are used to suppress emotional bodies and initiate relaxation states. But this is bad for people. Butylated hydroxyanisole disrupts neural signaling. Neurological and physiological effects of GMO-derived chemicals. So we have 1. Neurotransmitter disruption. Soy phytoestrogens mimic estrogen, disrupting serotonin and dopamine production. MSG overstimulates glutamate receptors, potentially leading to migraines, anxiety, and ADHD-like symptoms. It also damages the blood-brain barrier permeability. Glyphosate exposure from GMO crops can weaken the blood-brain barrier, allowing toxins to enter the brain. This is linked to neurodegenerative diseases like Alzheimer's and dementia. They are literally giving us foods that destroy the blood-brain barrier, and then we wonder why people have illnesses such as Alzheimer's. These chemicals are in all foods in the supermarket. More than 90% of the food contain these dreadful ingredients and chemicals. Oxidative stress and inflammation. Corn oil and canola oil promote inflammation via arachidonic acid, which affects the metabolism. Preservatives and pesticides residues generate reactive oxygen species, damaging brain neurons. The articles used within this publication regarding Alzheimer's, dementias, and cancer, the statistics are old. They are not present statistics. Further increases have likely occurred. If you search on Google, you'll generally only find statistics over the last 3 to 5 years, and publications only as recently as June 2024. Publications highlighting the increase. This is intentional. They are intentionally hiding the true figures. The alarm bells should be sounding, but they do their utmost to suppress the truth with subtle manipulation. According to the British Medical Journal, BMJ, there's been a 79% over increase. They discuss the factors I've presented, yet many turned a blind eye. Many of the ingredients used to produce our foods are highly toxic, and people should not just be encouraged to stop eating and drinking them. There's no reason for these chemicals and ingredients to be made in such a way in our foods, without it being intentional. The world is going through a cult, and they are intentionally making people ill and gaslighting them to the reasons why the increases are happening. We must collectively challenge these corporations and abandon their products if we're to survive, to cut down the pollution of the human gene pool, to stop our future generations suffering needlessly and dying at a younger age and unable to live a long, fulfilling life. This is crimes against humanity. Please see past the illusions and encourage your friends and family to become aware of what is occurring before it is too late. There's no conspiracy. It's presented to us with clear evidence and statistics and reports and peer-reviewed papers. And the statistics back up the claims that cases are rising and nobody's looking at the foods or accepting the situation for what it is. This section is taken from the UK's NHS primary care dementia data, June 2024. Links can be found highlighted in red. But these are some statistics taken from the page. Recorded dementia diagnosis. 487,432 patients had a recorded diagnosis of dementia on 30th of June 2024, an increase of 3,155 patients since May the 31st, 2024. Diagnosis rates in those aged 65 and over. 65% of patients aged 65 or over who are estimated to have dementia had a recorded diagnosis of dementia on June 30th, 2024, which was an increase from 64% on the 31st of May 2024. The young onset of dementia within young people below the age of 65 is increasing. 7%, 33,950 of those with a recorded diagnosis of dementia on June 30th, 2024 received their diagnosis before the age of 65. They are intentionally making people unwell through the food, air, water, and Pfizer jabs and other vaccines. There's no conspiracy. The data doesn't lie. Here are examples of how we can improve our levels of consciousness through diet by ditching processed foods. Humanity must survive. Without the ability to self-reflect, we will never collectively wake up. Summary: brain-boosting foods for emotional regulation and impulse control. Omega-3s, salmon, walnuts, improve brain function and emotional regulation. Leafy greens, spinach, broccoli promote cognitive health and reduce irritability. Nuts and seeds, almonds, pumpkin seeds, support mood regulation and impulse control. Berries, such as blueberries and raspberries, protect the brain from stress and inflammation. Dark chocolate, say, for example, 70% cacao, boost dopamine and mood. Whole grains, oats and quinoa stabilize blood sugar and prevent mood swings. Lean proteins, such as chicken and eggs, support neurotransmitter balance for mood and self-control. Turmeric reduces inflammation and boosts mood. Avocados, for example, enhance brain plasticity and support mood regulation. Green teas like matcha promotes relaxation and focus. And probiotics, lastly, improve gut health and influence mood regulation. So let's conclude this episode. Conclusion: the power of one. Many do not believe they can change the world. The truth is, we don't need to change the world. We need to change the world by changing ourselves, the choices we make and the actions we take. In understanding the interconnectedness of epigenetics, neuroplasticity, and the brain's delicate biology, it becomes undeniably clear that the environment we create, both internally and externally, have a direct impact on our mental, emotional, and societal well-being. Our brains are not fixed. They are adaptive, plastic, and responsive to experience. But when that experience is saturated with toxic food systems, environmental pollutants, neurotoxic chemicals like aspartame, and genetically modified substances designed for profit over people, we are unknowingly reshaping our minds in ways that strip away our autonomy, emotional balance, and cognitive clarity. And that's why many people cannot recognize what is happening because of the impairment that's occurring cognitively. The manipulation of diet is not just a public health issue, it is a tool of control. When our emotional regulation is compromised, when anxiety and illness become normalized, when serotonin and dopamine are suppressed at a mass scale, society fractures. We disconnect from self-awareness, from empathy and critical thinking, the very foundations of a conscious, empowered civilization. But we are not powerless. Through conscious choices, by reclaiming our diets, embracing brain-supportive nutrition, and awakening to the influence of our environment over biology, we can rewrite the story. We can rewire our brains, reclaim our emotional sovereignty, and rebuild society from a foundation of awareness, health, and resilience. The revolution begins not in the streets, but in the synapses and the connections we form within our brain and our internal realities that we reflect outwards of our being. Thanks for joining me today. I'm James, and this is the Inversiverse.